Okay, it's probably helpful if I turn on my microphone. What I just said was that I usually stream on Twitch when I'm playing video games and relaxing, but it's been a while since I've been on YouTube, and I just wanted to work on open muscle. I work on it quite a bit. I end up transferring everything. Well, this is not a solid state hard drive. I shouldn't tap it. I've been transferring everything over to some external hard drives, and I record a lot. So I figured I'll do two birds with one stone. I'm used to streaming anyways. I'm going to be working on open muscle. So what we have today is, of course, my place is always a mess because I'm always working on this. This is the open muscle, right? So I have the open muscle 12. So I'm going to start in a top level view with a top level camera. Open muscle started when I was just thinking that it'd be pretty easy to see that muscles are contracting in the forearm if you just pretty much have pressure sensors. And so I was just trying to find a inexpensive method of pretty much sensing these muscles that pull the tendons in your forearm for your hand, and to start an artificial neural network machine learning training process to see how efficiently or how much data is needed to actually find the patterns in the pressure sensor data to be able to discern what finger is being moved. I thought this would be a very inexpensive way to solve the prosthetic sensor problem. And I thought it would do some good. So I was working on some silly blinky light electronics project, and I realized I should probably spend at least some of my time doing something for humanity, or at least trying, you know. No, everyone, if you try and you document correctly, hopefully people can learn from your mistakes, and you're still, even if you fail, you're still helping in the long run. So that's the impetus for starting open muscle. There was so many different versions before this one, but now I mostly was using these little pistons with springs, and then on the end of the pistons are magnets, and then there's a Hall effect sensor on the PCB. These purple pieces, and I do believe I actually have the blank boards. So this is the PCB, and then on the back it has two slots for the Hall effect sensors. I will turn on my microscope for later. Might need that. So getting the wiring is getting the wiring is a little difficult. As you can see, the wires are kind of everywhere because each one of these lines is connected to an ADC, an analog to digital converter, where it takes the output of the Hall effect sensor. So as the magnets get closer to the Hall effect sensor, they register a higher voltage. And so that voltage is measured on the microcontroller, which is an ESP32. I have a whole bunch of them here. And this is one of the ESP32-S2s. But the spring system, it was difficult. I thought it would be effective, but they're just facing every direction in this design. It just was teetering. There's lots of issues. So recently, I've started replacing them with this with foam. My buddy actually recommended this idea, and he has his own YouTube channel. I'll link that. It's in Harry. It's the link on my main page. And try to glue this one back. The problem with the glue is that you don't want the glue to soak into the foam too terribly much, because if it does, it will make the foam rigid, right? And the difficult part about this whole thing is that the amount of force that we're measuring, that when the muscle contracts, pretty much the forearm muscle pressing in this foam, is very small. It's in between around 10 grams of force. Now, I know grams are not a unit of force, please forgive me, but it's from my measurements. That's the only measurement I have is grams, in between 10 and about 45 grams of pressure. And it depends on a lot of factors. But while that's setting there, oh, and I do need to create the foam one for this. So this is the little device I created. I just super glued magnets in here in the right orientation so that I can lay my rubber on top. So this system had a magnet, a clevis pin, a clevis pin holder, which is a PLA, a spring, a clevis pin cap, and then it even had these feet on top of that. So it's quite a lot of pieces. This is just consisting of a plate, foam with double-sided tape, rubber, and then the magnets. So it's a lot bit easier to create this. Took about 8 hours to put together the other bands. And this super glue works pretty well. Again, I'm trying not to put too much on there. And this is kind of my process. So I've been getting some good signals from this. The signals are great now that I have it in this orientation. So let me open up my Python folder. Hope everyone is doing well. And I'm gonna have to stop streaming here and come back. I have to take